Hi, my name is Nicholas Matus, and today I'll be walking you through our experiment to identify the composition of the sublimating ice sample from the south pole of the alien planet ATX 78757. This experiment was designed to determine the molar mass of the gas produced by the ice as it transitioned directly from a solid to a gas, a process called sublimation. Using the molar mass, we identified whether the ice was composed of carbon dioxide or methane. Throughout this discussion, I'll cover the experiment's objectives, the steps we followed, the results we obtained, and the conclusions we drew. I'll also touch on how we addressed potential errors and what we learned through this process.
The main objective of this experiment was to identify the chemical composition of the alien ice sample. By measuring key variables such as pressure, temperature, and gas volume, we aimed to calculate molar mass of the sublimated gas. This value would then be compared to the known molar masses of carbon dioxide and methane to determine which compound exactly would be compared and matched to our findings. Additionally, this experiment allowed us to apply theoretical gas laws, like the ideal gas law, PV equals nRT, to a practical scenario. Beyond identifying ice, the lab helped us understand how small changes in experimental conditions, like temperature or stability or condensation, can affect the accuracy of our results.
For our procedure, we began by preparing our materials, including a 250 milliliter Erlenmeyer flask, rubber stopper, distilled water, and a sample of the ATX 78757 ice. After ensuring the flask was clean and dry, we measured its volume by filling it with water and transferring the water into a graduated cylinder. This step ensured that we knew the exact volume of gas the flask could hold. Next, we weighed the empty flask on a balance to record its initial mass. It was crucial to handle the flask casually to avoid adding fingerprints or condensation that could alter its weight. After this, we added a small amount of the ATX 78757 ice into the flask using tongs to avoid direct contact, as the ice was extremely cold and could cause burns. We then placed the flask in a water bath to stabilize the gas temperature at 25 degrees Celsius or 294.15 Kelvin, ensuring the gas inside the flask was at an equilibrium with the surrounding environment. Sublimation was allowed to complete, meaning the ice fully transitioned into its gaseous state. After sublimation, we carefully wiped the flask to remove any external moisture and reweighed it to determine the mass of the gas. Simultaneously, we recorded the atmospheric pressure using a barometer, which was 0.996 atm during the experiment. Finally, we used three measurements: mass, volume, pressure, and temperature. Four measurements: mass, volume, pressure, and temperature in our calculations to determine the density of molar mass of the gas.
The results of our experiment provided clear evidence that the ice sample was composed of carbon dioxide. The density of the sublimated gas was calculated to be 1.201 times 10 to the negative third grams per liters, which aligned with the expected values for CO2 under the given conditions. Using ideal gas law, we calculated the molar mass of the gas to be around 44.01 grams per mole, a near exact match for carbon dioxide. To ensure accuracy, we accounted for the density of air in the flask, which is calculated as 0.3367 grams per liters. Subtracting this value from the total mass helped us isolate the mass of the gases alone. The combination of accurate pressure, volume, and temperature measurements allowed us to derive reliable results. These findings were consistent across multiple steps of our calculation, supporting the conclusion that the ice is indeed carbon dioxide. This result is significant as it helps confirm NASA's hypothesis about the composition of ATX 78757 South Pole ice, contributing to their understanding of the planet's environment.
Our experiment demonstrated how the ideal gas law and related equations can be applied to identify unknown substances. By carefully measuring key variables like pressure and temperature, we were able to calculate the molar mass of the sublimated gas with precision. The results aligned closely with the expectations, confirming the gas was carbon dioxide. However, the experiment was also highlighted potential sources of error. For instance, condensation on the flask during sublimation could alter the mass readings. Additionally, fluctuations in the atmospheric pressure or slight variations in temperature could impact the calculations. To minimize these errors, we ensured the flask was completely dry before each weighing and used a stable water to maintain a consistent temperature. The accuracy of our results demonstrates the effectiveness of the experimental design, but small improvements could make it even more precise. For example, using more sensitive pressure measuring instruments or conducting multiple trials could help identify and reduce variability. But overall, this experiment not only achieved its objectives but also provided insights into challenges and considerations involved in accurately identifying unknown substances.
In conclusion, our experiment successfully identified ATX7857 ice sample as carbon dioxide, with a calculated molar mass of 44.01 grams per mole. By applying the ideal gas law and accounting for variables like pressure, temperature, and volume, we confirmed the identity of the gas and supported NASA's research on the planet's chemical composition. While minor sources of error were noted, the results were consistent and reliable. This lab provided valuable experience in applying theoretical concepts to practical scenarios, highlighting the importance of careful measurement and error control in scientific experiments. Thank you for watching. I hope this video was enjoyable and clarified findings in this lab.